All right, so today we are looking at 1.6 in our textbook, which is trigonometric functions. And our goal for today is to really understand the unit circle, understand where points are coming from on the unit circle, and to be able to identify our trig values rather easily. So what we want to do then to start is on that front page, I gave you basically all the table of values. So the only thing that's not on that front page, which is kind of unfortunate, is the radians. So we can convert all degrees to radians by doing a simple conversion. So if it's helpful to you, we can convert all of the degrees to radians to start. So let's do that for a minute. Okay, so we're going to go over and we're going to put down next to all of the functions and their degrees, their radians. So 30 degrees is the same as pi over 6. 45 degrees is pi fourths. 60 degrees is pi thirds. 90 degrees represents the top part of the unit circle. 90 degrees is pi halves. And then we also know that 120 degrees is going to be similar to 60 degrees. So you have two ways you can go about finding 120 degrees. You either can have it memorized or on a calculator. What you would do is take that 120 and multiply it by pi, but we're not going to type the pi in. So we're going to multiply it by 1 over 180 and get that in fraction form. And what we notice is 120 divided by 180 is 2/3. So again, that should make sense. 60 degrees is pi thirds. So 120 is 2 pi thirds. So all the 60-degree reciprocal angles will always end in 3. All of the angles that end in 5 will end in 4. So we have 1/4. And then over here, we have 3 pi fourths. And then 150 is the same as 30. So it's going to end in a 6. And it is 5 pi 6. Okay, so then let's finish that for the remaining problems on that handout. So 180 is pi, it's half the unit circle. And then all of the 5s, like I said, are your fourths. So 225 is going to end in a fourth, 315 is going to end in a fourth, and it goes 1/4, 3/4, 5 pi fourths, 7 pi fourths. 360 is 2 pi. It's making your way all the way around. And then 210 and 330 are both going to represent my 30 degrees. So they're going to end in 6's. And 210 is 7 pi, 6, and 330 is 11 pi, 6. 270 is 1.5 of our unit circle's circumference. So we have pi. 270 is 3 pi halves. And then 240 and 300 are both going to represent our 60-degree angles. So 240 is 4 pi thirds, and 300 is 5 pi thirds. So again, I put that sheet up on the front for you. I think it is super helpful and nice to have all of your trig values right there in front of you. It helps you to see exactly what value goes where, and it's going to be helpful on that next page. So on the next 2 pages, you have a blank unit circle. I gave you that as practice in order to help you get an understanding of what we are looking at. I actually thought I put these. So I put the unit circle actually on here. So I'm going to give you a few minutes to at least copy down part of the unit circle. The unit circle encompasses our idea that all students take calc. So all students take calc, give the quadrants in which all are positive, sine is positive, tangent is positive, and cosine is positive. In calc, we primarily use radians. So again, I gave you the radians on this unit circle. We don't use degrees very often, but I know that those of you taking AP Physics use degrees. So it's helpful to be able to convert between the two and know where the two lie. The values inside the parentheses are your sine and cosines. And then the value outside is the tangent. Again, a lot of the values are repetitive, so if you can memorize quadrant 1, you can memorize them all. All right, so now that you've copied down the unit circle, what you'll notice is the very next page in our notes packet is a unit circle worksheet. So that is part of your assignment. It is also on Fusion for those of you that don't have the packet or if you've misplaced it. So you can use those first 2 pages to do that unit circle worksheet. The unit circle worksheet is going to be similar to the unit circle quiz, where I will give you a trigonometric function. I'll give you an angle, although mine for our quiz will be in all radians at that point. And then I'll expect you to give me the answer that makes it true. So that kind of sums up how and what we need to know for the unit circle. The next part of what we need to look at is looking at all of the arcs and measures. So again, here's that unit circle worksheet that I was just talking about. You want to reference this idea. I hinted on the all students take calc when you were doing your unit circle, but the idea is that all means they're positive in quadrant 1, negative positive in 2, negative negative in 3, and positive negative in 4. And the big idea is, do you know quadrant 1? If you memorize anything at all, it would be this slide, so that you can basically use it to get you all your other key points. We're going to talk a little bit today about the key points of 0, pi halves, pi, and 3 pi halves also. Radian measure. Radian measure is the measurement of an angle at the center of the unit circle equaling to its arc length on the outer edging of our unit circle. So the radian measure of angle ACB at the center of the unit circle will equal the length of the arc ACB that cuts from the unit circle. For arc length, we use the formula S equals R theta. For arc length, we use the formula S equals R theta. Where S represents arc length, R is the radius of your circle, and theta is the angle of the circle that you are looking for the measure of. So it says find the length of an arc subtended on a circle by radius 3 with angle measure. Well, there's a typo. It says angle measure. With angle measure 2/3. So what you want to do is plug into your formula. So we know we're applying S equals R theta. Our R value is 3. And our angle is 2 pi thirds. So we get S equals 3, 2 pi thirds, or the arc length is 2 pi. An angle of measure theta in standard position at the center of the circle with radius r can be defined using the 6 trigonometric functions. So that table that's on there, that's going to be on the next slide. Don't worry. Basically, what we're doing is we are looking at this idea. The length here, this is called the terminal ray. The initial ray is always the x-axis of the unit circle. So an angle in standard position goes from the initial and out. You can go down. So when we talk about radian measure, we actually never make it to quadrant 3. So an angle in standard position is only going to come from quadrants 1, 2, and 3, because we can get all the major trigonometric answers from those quadrants. So standard position will never come from quadrant 3. The 6 basic trig functions are defined as the following. y over r for sine, x over r for cosine, and y over x for tangent. The r, when we define these functions, is representing or relating to the radius. So you'll notice over here, this is kind of like Pythagorean theorem. Remember, the Pythagorean theorem is just a variation of both the distance formula because Pythagorean theorem represents the distance from point A on a triangle to point B on a triangle. And basically what you're doing is you're finding R. So like R is equal to the distance from x1 to x2 and y1 to y2. Where this would be point x1, y1, and up here is point x2, y2. Oh, I didn't realize it was cut off the meter. Okay. This is also where we start to think about or reflect back on good old SOHCAHTOA. So when we're talking about our triangle, y and r represent those points, but they also represent the lengths across from the angle, which are opposite hypotenuse, adjacent hypotenuse, and opposite adjacent, depending on which trigonometric function you're talking about. So as I mentioned earlier, in here, we're primarily going to work in radians. So when you're in here, your calculator should be in radian mode. And we have two conversions. You can convert radian to degrees and degrees to radians. So both of those conversions are listed up there for you. So again, our textbook will use radians for all angle measure if they do not specify. So everything is in radians unless they specify. Pi thirds, we don't usually say it, but that means pi thirds radians. Again, we know that's equivalent to 60 degrees. Do not ever tell me pi thirds degrees. Okay, so we can find our trig values by doing a simple problem. So we're given that sine of theta is equal to negative 3/5. And we're also told that the tangent of theta is negative. So the reason for being told both of those pieces of information is that the sine of theta can be negative in two quadrants. And we need to find the quadrant in which sine of theta is negative. So if we think back to the idea here, all students take calc. The sine of theta is going to be negative in quadrants 3 and 4. However, the tangent of theta is only negative in quadrants 2 and 4. So their overlap occurs in quadrant 4. So what that means is that this triangle lives in quadrant 4. Remember that sine of theta is y over r. So that's kind of like saying this goes down 3 on the x coordinates. And I have a radius of 5. So I need to use Pythagorean theorem to find x. So I have x squared plus y squared equals r squared. The radius we don't give the negative value to because a radius length can't be negative. So if you have a negative on your sine, cosine, tan, etc., it never goes to the r. So we get 3 squared, which is 9. So you get x squared plus 9 equals 25. Subtract 9 from both sides, and we get 16. So what that means is x is equal to 4. And I know that since the tangent is negative and sine is negative, cosine is positive. So my r is the positive part of the square root. So that means this graph goes 1, 2, 3, 4. So this graph or triangle exists in quadrant 4. And there's my triangle as it lives. Theta is always going to be with respect to the angle made with respect to the x-axis. So theta is in that corner over to the left. And again, my height is -3. My base would be that 4 and your radius 5. So I can use this idea to find the 6 trig functions. So we were given sine. Cosine is positive 4/5. Tangent sine over cosine, so it's -3/4. And then our other 3 trig functions are simply the reciprocals. So cosecant is -5/3. Secant would be positive 5/4. And cotangent is -4/3. So I found all the trigonometric values of theta given 2 conditions. So again, finding those 6 values, finding our trig values are all very related. So we want to use our table or chart to find the missing trig values in this problem. So we have sine of 3/5. 3/5 is in quadrant 2. So sine is positive. Anything that ends in a fourth is going to end in a 2. And 3/4 is positive root 2 over 2. Cosine of negative 3/4 is kind of like imagining the unit circle. And instead of going counterclockwise like we're supposed to, you would go clockwise. So you'd start at 0 and you'd go backwards, however many it went backwards. Now in this case, we're going backwards, negative 3/4. So that would put me in quadrant 3. You can also find its congruency statement. So what that means is negative 3/4 is equal to the angle adding 2 pi to it, because basically you're just looping the unit circle. So in order to find its equivalent angle, you would just add 2 to negative 3/4. And again, we get that positive 5/4, which exists in quadrant 3. So cosine of negative 3/4 is equal to the cosine of 5/4, which is equal to negative root 2 over 2. The tangent of 5/3, 5/3 lives in quadrant 4. It's the same as 300 degrees. So the tangent of 5/3 is negative root 3. Cotangent of 11 pi over 6. 11 pi over 6 is 330 degrees. It lives in quadrant 4. That's the same as 1 over the tangent of 11 pi 6. So that is negative root 3 over 3. The secant of 4 pi over 4. Don't let the 4 pi over 4 trick you. That's really just the same as saying the secant of pi. So secant of pi is the same as 1 over cosine of pi. Cosine of pi is negative 1. So 1 over negative 1 is negative 1. Cosecant of negative 11 pi over 6. Well, that's the same as going down pi 6 from 360. So it's 11 pi over 6. So cosecant of 11 pi over 6 is the same as 1 over the sine, which would be 1 over negative 2. Or, sorry, 1 over negative a half, which gives you negative 2. Sine of 4 pi thirds. So 4 pi thirds lives in quadrant 3. The sine of 4 pi thirds is going to be negative root 3 over 2. Because again, any pi thirds for sine is root 3 over 2. And then because we're in quadrant 3, it is negative. Cosine of negative 8 pi over 4, you need to simplify your negative 8 over 4 to start. So you get the cosine of negative 2 pi. Well, you'd add 2 to that, which becomes the cosine of 0. And cosine of 0 is 1. Okay, the tangent of 5 pi over 4. So again, we're talking about quadrant 3. Tangent is sine over cosine. Well, sine and cosine at any pi fourths are root 2 over 2. So sine and cosine at any fourths is the same, which means tangent is always a 1. And because tangent is positive in quadrant 3, we get positive 1. 3/6 is the same as pi halves. And we know that the cotangent of pi halves is going to give you cosine over sine. Cosine of pi halves is 0, sine is 1. So 0 divided by 1 is 0. 5 pi thirds is in quadrant 4. Secant has the same sign as cosine, so cosine's positive, therefore secant's positive. The cosine of 5 pi thirds is a half, so the secant of 5 pi thirds is 2. And 7 pi over 6 lives in quadrant 3. Cosecant in quadrant 3 is negative, so I know right away my answer is negative. And cosecant at a sixth is always a 2. So it is negative 2 in quadrant 3. Okay. On that slide I gave you, these are problems. Just FYI. These are the Pythagorean triples. We do a lot with triangles in calculus. We do a lot with looking at the Pythagorean theorem. So in that one previous problem, we had that sine was equal to negative 3/5. Well, the minute I saw the 3 and the 5, I knew that was going to be a 3, 4, 5 triangle. I actually didn't need to do the Pythagorean theorem because I knew the other leg was 4 because it was a Pythagorean triple. We have 2 main Pythagorean triples, and then we just use their multiples. So the 2 main ones are 3, 4, 5, and 5, 12, 13. A 6, 8, 10, a 10, 12, 26, a 10, 12, 10, 24, 26. These are all variations of that. So basically you can multiply these 2 original Pythagorean triples. And as long as you multiply all 3 numbers by the same number, you can get a new Pythagorean triple. So if I took the 3, 4, 5 and I multiplied everything by 5, you'd get a 15, 20, 25. That is still a Pythagorean triple, and it's still a right triangle. So in the textbook, you're doing 1 to 10, and then you're also doing that first unit circle worksheet